Good afternoon, everyone. My name is Domenica Triago. I'm part of Dr. G's Chemistry 1 laboratory class at Palm Beach State College, and today I will be talking about experiment 11, which is the oxidation and reduction titration. So a little bit of an introduction. In terms of electrons, what is meant by the term oxidation? In terms of electrons, oxidation would be the loss of electrons or increase in the oxidation state of an ion or an atom in a molecule. So what is meant by the term reduction in terms of electrons? The reduction would be the gain of electrons or a decrease in the oxidation state of an ion or an atom in a molecule. And then what can we expect today about the color change of the titration? The analyte will go from pale green solution to yellow-red solution when the purple titrant is added to it. I added this picture that I saw on the professor's PowerPoint, and I went ahead and looked at the link, which I'm gonna definitely put in under the description so you can go check it out. But I think this is the most accurate and just perfect picture to show what we're gonna be doing today. So if you see the last picture where you see the red solution, that is past the endpoint, and then the picture to the left where we see our yellow-red solution, that would be our endpoint. So the chemicals we're going to be using today will be KMnO4, which is our potassium permanganate, the dark purple solution in our titrant, and then FeNO3, which would be our iron 2 nitrate, the pale green solution in our analyte. Now for the materials we're going to be using today, we have our Erlenmeyer flask. We need 3 of them. Then we have a beaker. Then our deionized water. We have our volumetric pipette and pipette bulb. Our burette and burette clamp. And our stamped glass funnel. So for part A would be the preparation of the burette, meaning that the first step would be place the burette in the burette clamp, and then we have to use a stamped glass funnel on top of it and pour a small amount of milliliters of potassium permanganate to rinse the burette. Then using a designated waste beaker, empty the solution through the stopcock and repeat this process twice. And after rinsing, fill the burette with new potassium permanganate. Make sure to not overfill it. And if any air bubbles appear, gently tap the burette with your finger. And make sure you record your volume reading. Then for part B, this is where we actually perform the redox titration. So we have to collect 3 250 milliliter Erlenmeyer flasks and 80 milliliter of an unknown solution, which is going to be our iron 2 nitrate. We have to use a volumetric pipette and the pipette bowl to transfer 25.00 milliliters of the unknown solution of iron 2 nitrate to the Erlenmeyer flask. Then we will label the flask and repeat this process twice with the other 2 Erlenmeyer flasks. Now we slowly have to add the potassium permanganate from the burette to the Erlenmeyer flask with the iron 2 nitrate. And then do not forget to swirl it. We have to repeat if we have enough solution, so we can do this experiment 3 times because it's going to be performed in 3 trials. And please just make sure to not go below the 50.00 milliliter mark if you would like to perform another titration. If you happen to need more solution, just repeat part A. Thank you so much for watching. I hope this was helpful, and I won't see you next time because this is the last video, so I hope you enjoyed it and this was helpful.